Good morning, all of you. My name is Meghana. I am from Triple E. Today, my topic is energy loss minimization by optimizing space configuration. Subject: performance of transmission lines and cables. Institute of the Aeronautical Engineering College, Dundigal, Hyderabad. My name is Meghana, BTech, 5th semester. Introduction of this topic: energy loss minimization by optimizing phase configuration. Introduction to energy loss in power systems. Energy loss occurs during the transmission and distribution of electric power. Minimizing these losses is crucial for improving efficiency and reducing operational costs. Optimizing phase configuration is a promising approach to achieve significant energy savings. Fundamental of this topic is fundamentals of power transmission. Power transmission involves moving electrical energy from generation source to end users. Losses primarily occurs due to resistance in conductors and reactive components. Proper phase management can influence the flow and reduction of these losses. Understanding phase configuration. Phase configurations refers to the relative phase angles between multiple power source and loads. Adjusting phase angles can influence power flow and reducing circulating currents. Optimized phase arrangements can lead to lower overall energy dissipation. Types of power losses in transmission lines. Resistive R square R. This is the formula of power loss. Losses are caused by the current flowing current through conductors. Reactive power losses arise from inductance and capacitance in the system. Both type of losses can be alleviated through phase optimization techniques. The role of phases is power systems. Synchronous generates operator with specific space relationships to ensure stable power delivery. Phase shifts can be caused undesired power oscillations and increased losses. Managing the phase angles helps in maintaining system stability and efficiency. Mathematical modeling of phase optimizations. Power flow equations are used to model the relationship between phase angles and power losses. Optimization algorithms aim to find the phase angles that minimize the total losses. Constraints including system stability, voltage limit, and operational safety. Techniques for a phase configuration optimize for this topic. Heuristic method such as genetic algorithm and practical swarm optimization are common. Convex optimization techniques provide efficient solution for linearized models. Machine learning approaches are emerging for real-time phase adjustment. Transmission loss reduction. Implementing phase adjustments lead to a 15% decreases in energy losses in a regional grid. The study demonstrated the importance of dynamic phase control in a complex networks. Results indicate improved power quality and reduced operational costs. Benefits of phase optimization: significant reduction in transmission and distribution energy loss, improved overall system efficiency, and reliability, potential for integrating more renewable energy sources with minimized losses. Challenges in phase configuration optimization. Accurate system modeling is essential but can be complex and data intensive. Real time adjustments required advanced control systems and communication infrastructures. System constraints and regularity policies may limit the extent of phase modification. Integration with the smart grid technologies. Grids enable real time monitoring and adaptive phase control. Advanced sensors and automation facilitate dynamic losses minimization tra- strategies. Combining phase optimization with the demand response enhances energy efficiency. Future direction in energy loss minimization. Development of a more robust algorithms for the large scale real time optimization, incorporation of renewable energy variability into phase configuration models, collaboration between system operators, research and policymakers is essential. Practical considerations of implementations. Ensuring ensuring compatibility with existing infrastructure is critical. Cost benefits analysis helps justify investments in the phase control equipment. Training personnel and establishing operational protocols are necessary for success. Conclusions and summary of this topic is optimizing phase configuration offers a variable pathway to reduce energy losses. It requires a combination of advanced modeling optimization techniques and smart technology. Continued research and technologies advancement will enhance the effectiveness of these strategies. This is the topic about energy loss minimizations by optimizing phase configurations. And this topic we have discussed about introduction to energy losses in power systems, fundamental of power transmissions, understanding phase configurations, and type of power losses in transmission lines, the role of phase in power systems, mathematical modeling of a phase optimizations and techniques for phase configuration optimization, case study of a transmission loss reduction, benefits of phase optimizations, challenges in a phase configurations optimizations, integration with the smart grid technologies, and future directions in energy loss minimizations, practical contents for implementation, and conclusion and summary. We have discussed about this topic in energy loss minimizations by optimizing phase configurations. Thank you.